Hello, Forecaster here again, and we are back for episode 46 of the Railcraft server Let's Play. Currently not taking place on the Railcraft server, ironically enough. We're back in the test world, of course, and I've been working a little bit on the reactor program off camera. I did actually record it, but I messed up, so the recording was not usable, which is a little unfortunate. So things are a little different, and I don't remember quite how it looked when I when I last ended. So forgive me if I miss something, but one thing I've changed is the reactor layout, and I don't think I showed this in the last video, not as far as I could see at least. But I was pretty much using the one I used on the server previously, but that didn't seem to be stable anymore. So I made this one instead using the reactor planner, or one of the reactor planners, planner applications, and this is stable for at least one run, or one cycle, so it can burn through the cells completely without any components failing or anything like that, assuming that it's able to output the heat and such. We seem to have run out of coolant somehow, and I'm not sure how that happened. Oh, maybe it was... Oh, right, I blew up the reactor, and all the coolant was probably destroyed when that happened. So we're going to have to put in some more. I did also change the program a bit. I added something. Oh, right. There's some heat left. It is off currently, so the reactor is not running. I know that for sure. But it seems that we have some heat left in the components still, so that is being output, balanced into the core, and then or pulled from the core and then output into the coolant. Anyway, let's switch to IntelliJ again, and let's see. One thing that's definitely new is this bit down here. I had an issue with when I shut down the program, the reactor would keep running because the redstone signal remains on, which is bad because when you shut down the program as sort of an emergency shutoff, you want the reactor to stop. So when the program ends, when the main loop ends, it's going to unregister the shutdown, the interrupt events, and then it's going to set the two outputs to 0. It turns off all the redstone outputs, which will turn off the reactor. So if the reactor is about to explode, you can shut down the program and it will stop everything. And that may be it. Now I'm going to add a function which I think is in my clipboard. Yes. Which I found on the internet, of course, and I haven't really looked at what it does, but it rounds this number to this number of decimal points, So what we can do then is in the print here, we can do round, and then we can say 2 decimal points there, and then round that to 2 decimal points there. And then we're going to push that to the game. So now when I start the program again, you can see that it is not printing a whole bucket load of decimal points. It's just printing 2 at most. So, right, and then we want to, let's see, we want to do that times 100. Oh, I forgot to switch back to the game. Dang it. Right, let's switch back quickly. You can see here that it prints 0.98 and then 1 because it's still a decimal value, so 1 is 100%. Here it's printing, for power, it's printing 8%. So we're going to go back to IntelliJ now properly, and then we can add a percentage sign there, and then we can do times 100 and then add a percentage sign there as well. And now we'll go back to Minecraft. We'll rerun the program, and now we have a proper percentage readout. Which is nice. So this tank is full, of course, or pretty much full. So it's showing 100%. This, it is outputting heat into here. So we have power production, and that's gone up to 9%. So power is increasing. Now this should be stable. It looks like it's not producing enough heat to keep up with the drain, which means that it's going to run out. But it should keep going until... Alright, because the reactor was not running, of course. So this is going up now. Right. So hopefully this will produce enough power to keep up with these now what we want to do as well is add a control that checks the level of this MFSU, and it's going to basically, we want something similar to the level control. Let's pop back to IntelliJ quickly. So we have this block here, which controls the pipe output, and we have it set up so that when it goes above 80%, it's going to start outputting hot coolant into the coolant processing, and then if it dips below 10%, it's going to stop. And we want something similar for the power level. So we want it to, when it dips below, say, 2%, because this is a lot more granular, or let's say 5%, something like that. We want it to, we know it's nearly out, so we want it to turn everything on, and then it's going to start producing power, and then it's going to keep doing that until it gets to, say, 90%, and then it's going to stop. And we don't want to go for 100%, because while it will stop outputting hot coolant from this tank, there's still going to be a bunch here that needs to run out, and then this is going to have to process any remaining heat or steam, and then these may have, well, they're not going to have any power stored up actually, but there's still going to be some coolant to process, so that's going to produce some amount of power. So we want to leave some space for that, just to be safe so we don't lose anything. So having margins is good. But yeah, so it looks like this is actually keeping up fine. So we're going to shut this down. So we're going to stop the program, and it turns the reactor off. It will cut the flow of hot coolant from this tank immediately, or pretty much immediately. And then we are going to go back to IntelliJ, and we want to bake the power check into this check here, because we want there to be so this is, so this is a little tricky, because we need a bit of logic here. We want it to only turn on or start producing power if, say, the MFSU is below 10% and the tank level is above 80%. So we want and capacitor level is below 0.1% or 0.05, so 5%. Then we want it to turn off or stop producing power if the tank level is below 10% or capacitor level is above 90%. Or let's say 95%. Now there is a little bit of a quirk to this, and that is that since we have a lot smaller capacity in the tank, and I'm trying to think of a good way to imagine this, or to visualize this. Let's go down here. Let's say that this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is our power storage, and this is the actually, let's double this. This is our tank, and this is the MFSU. Now, let's say there's a bunch of power in here. So let's say this is about half full, and this is completely full. According to the logic we have set up, currently nothing is going to happen because the MFSU is half full, and nothing, while the tank is above 8%, the capacitor level is not below 5%. However, when this goes down to, say, here, let's say this is about 5%. We have run it through the power we have stored up, and this has gotten low enough that this is true. Now, God damn it, the tank level is above 80% because the tank is full. So it's going to turn on the redstone signal. It's going to start pull coolant, hot coolant, out of this tank. It's going to turn it into power. So this is going to go down, and this is going to start going up. Now, it's going to run through this, and it's going to produce some power. Not a lot of power. Then this is going to get low enough that it goes below 10%, which means that this is true. This is not going to be true for quite a while. But now the tank level is low enough that this is true, so it's going to turn off the pipe, and it's going to stop extracting hot coolant from the tank. And since the coolant is also low enough, it's below 90%, it's going to turn on the reactor and start producing more. So this is going to fill back up. But the MFSU has enough power that it is above 5%, but it's not very full. But since it's above 5%, this is now false. It's not below 5%. And while the coolant tank is now full again, or close to full at least, it's above 90%. But this is not going to turn back on until we use more power so that the MFSU is below 5% capacity. So it's not going to run up, it's not going to start up again when the tank is filled up until this has filled or drained back down below 5%. And off the top of my head, I can't, no good way of designing this logic so that it will keep the cycle going, filling up the tank, then draining it, filling up the tank, then draining it, until this is, until this triggers. Except changing this so that it is true when this is below 95%. or below or equal to 95% is probably what you want to do. Now, this is probably not going to be a problem for the current reactor that I'm using in this test setup, and will probably be using in the server, because it produces enough hot coolant to keep up with the drain. However, if you wanted it to be more efficient, or as efficient as you could get it, you could add more coolant processing units and then split the coolant between them, which would overdraw coolant more than the reactor could produce, which is probably not what you want, actually. You would probably want to keep the reactor so it produces more hot coolant than what the processing drains. But I would want the program to be able to handle that scenario as well, if someone were to do that. So I might have to think of this off camera to figure out a solution to this little caveat. But it's not a huge deal that it does that right now. But it's something that I would like to fix eventually. So let's fill this MFSU up a bit, because I want to see the program shut off the reactor or coolant output when the MFSU fills up completely. So we set it to 95%. It stores 40 million. So I'm going to calculate that. So let's see. 40 million times 95. So that's 2 million is what we need to fill it up to 38 million approximately, or just below that, of course. And then when it gets above 38 million, it should shut down. Then I have the next thing we're going to do is I'm going to replace this creative computer case with a server. I'm going to design the program around that instead. And we're going to make it so that we can get the status of the reactor, whether it's running, the heat level, power level, coolant level, things like that, on a tablet through a wireless network. And since we have about 5 minutes left, we are probably going to have to do that in the next episode. So I hope you don't mind some more programming, which that is obviously going to be. So we're going to get that set up. And then we're, of course, going to set this all up on the server in the end, which is I haven't been on the server since I started working on this because I can't really do a whole lot without the reactor functioning. So I need to get this working first. Right. I'm probably just going to fill it up because this doesn't produce a whole lot of power, so getting up to 38 is going to take a little bit unless I fill it up to just below that. So let's grab some of these. And setting up the network stuff is going to be fairly easy. Fortunately, it's not too difficult. We just need to design a client and then add some stuff to the reactor manager to manage the server stuff, to be able to respond to requests and such. Pretty much it's going to be similar to how the elevator programs work with the client and the server and the ports. The server is just going to sit there, manage the reactor, and wait for requests from the client. And then the client is just going to send requests when it needs data. It's going to receive the data and then display it. And I'll make some nice bars and stuff and some readouts. Probably have a button that allows you to force shut down the reactor remotely. So now we have 37.2 million energy units in here. I might want to put in a few more just to get a bit closer. Well, because I don't know how long it's going to take with just 150 EUs per tick output. Let's put in one more advanced RE battery. And I suppose we can turn this on. Maybe. Okay, we're almost at 37.5, so that should do. Let's turn this on. Okay, we're at 94, so pretty close. So this should be heating up. No? Is it? Did I put in too much power? Oh, wait. Right. That is... It's not going to start the react or start pulling until it gets below 10%. So we're going to quickly modify this so that this will engage if it's below 95. So let's do that. Uploaded that. So now it should... Yeah, there we go. Right. Maybe I'll leave it like that. It's a pretty easy fix. And it will do for now. It's not really conducive to the cycle idea, and the reason that I wanted to drain almost completely before turning it on again is because this requires heating up. And like I said in the previous video, you want, at least I think I said in the previous video, maybe I said it in the botched recording, you want long cycles. So you heat this up once, and then produce as much power from that as possible, and then shut down. This will cool down to room temperature or environment temperature. And then you lose a bunch of power doing that, because that heat that is lost when you cool down, you don't get that back in any way. So you want to do that as few times as possible. So you want to utilize this when it has heated up for as long as possible. So this is going to be a bit less efficient. So I'm going to want to fix that eventually, like I said. So this is almost at temperature. There we go. Now we have power production going. This once it hits 95, actually it's going to go until it hits 96, isn't it? Because I set it to above 95. Or no, less than. Capacitor level is less than 95, so it's going to stop when it hits 95. So this is going to need to go up to 38, which by the looks of it at this rate it's going to take a while, so let's give it a little boost. As I thought, it's not really producing all that much power. Or the rate isn't very high, so we'll help it along a little bit. So now we are at 37.7 million. Let's help it along a little bit more. We want it to get up to 9. And we should probably stop. And then just watch. Okay, there we are. Close. How are we doing? Oh, we are at 95 now. So these flow should stop any minute. This might actually be an artifact of rounding. It might not actually be at 95% yet until it gets up to 38. It's just displaying that because of the rounding function. So now, yeah, now it's shut down properly. So maybe I want to find a more precise rounding function. But yeah, so that works for now. And I'm going to end the episode here. And like I said, the next one we're going to have a look at. Hopefully I'll be able to show the fix for this power issue so I can get proper cycles. And then we're going to have a look at the client server stuff as well. So with that, I will see you then.